Hello everyone. In this video we are looking at the oxygen dissociation curve or the oxygen binding curve. This is a very important concept for first year medical students, and many a times students tends to forget this in second year or maybe in third year. So right now you're looking at an oxygen dissociation curve. I agree, it's not a very artistic curve. It is made by me in Microsoft Paint. So let's discuss the black line. This line on which the arrow is pointed is a normal oxygen dissociation or oxygen binding curve for oxygen. The oxygen binding curve depends upon various factors including blood pH and the quantity of hemoglobin and some other variables. We'll be looking at those variables, the conditions leading to right shift of the curve and the conditions leading to left shift of the curve. These are the two conditions, and we have developed some mnemonics for that, remembering these things. You just have to remember, when the oxygen binding curve moves to right, it means more of the oxygen is delivered to the tissues. This part here, the red part, when the curve moves this side, more oxygen is delivered to the tissues. That means oxygen is less avidly bind to hemoglobin. That is why it is being released more in the tissues. When the curve moves to left side, this blue part here, it means that less oxygen is available for the tissues, or in the other words, a large amount of oxygen is avidly bound to the hemoglobin due to its increased affinity or a certain number of other causes. We'll be looking for both the causes, and we have developed a short mnemonic for both of them. Let's move. Shifting to the right. As I told you earlier, this will lead to unloading of oxygen from hemoglobin and hence increased oxygen delivery to the tissues. Increased oxygen delivery will be important in case of fever, inflammation, infection, because the myeloperoxidase system is utilizing oxygen to kill the pathogens, so oxygen needs to be delivered there. This, apart from other conditions, will cause shifting to the right. Let's see the mnemonic. This is a very simple mnemonic which is developed by me. Hat is black. Hat is black with B capital and leave the last four letters. Hat is black, increase everything here. In the left shift, you will have to decrease everything. That's all. That's the basic mnemonic. Hat is black, increase everything. H, increase in H positive ions, that is acidosis, will lead to right shift. Increase in altitude, where you need more oxygen to be delivered to the tissues, that will also lead to right shift. Increase in temperature, as I told you earlier, fever, because oxygen is needed by the tissues for inflammation, for the neutrophils to carry out oxygen dependent killing of pathogens. And B is 2,3-bis phosphoglycerate. Increase in 2,3-bis phosphoglycerate will also shift the oxygen curve to the right. There is very less quantity of 2,3-bis phosphoglycerate in fetal hemoglobin, so you must make this logic that fetal hemoglobin will lead to left shift of the curve. Yes, let's move on. This is again the curve I am reminding you. This is the right part which we have done just before. Now we'll move to the left shift. Remember, in the left shift, oxygen is more avidly bound to the hemoglobin. There is less delivery of oxygen to the tissues. Let's move on. Shifting to the left. This will lead to sticking of oxygen to the hemoglobin and hence decreased oxygen delivery to the tissues. Let's see the mnemonic here. It's a similar mnemonic except for the A. Hat is black. Just erase A there and then decrease everything. In the right shift, you are increasing everything. In here, you decrease everything. And also add all the abnormal hemoglobins like fetal hemoglobin, methemoglobin, carboxyhemoglobin. All the abnormal hemoglobins, you add it here. And hat is black, without A, decrease everything. H, decrease in H positive ions, that is alkalosis. T, decrease in temperature, hypothermia. B, decrease in 2,3-bis phosphoglycerate. As I told you earlier, increase in 2,3-bis phosphoglycerate will shift the curve to the right. decrease will shift the curve to the left, so less delivery of oxygen to the tissues. And almost all, not exactly, but the majority of abnormal hemoglobins fall into this category. Fetal hemoglobin, methemoglobin, carboxyhemoglobin are such examples. Hope you liked the short review of oxygen dissociation curve. For more of these kind of fast review videos, kindly subscribe to our channel.